Hey guys, I wanted to come back with another postbag video. I actually opened this before filming, so I'll just do a review of the items that were inside. But I'll start with the big one here. Basically, this is a power supply module for, come on, focus. This is a power supply module for breadboards. Uh, Basically, it just plugs in. If you have a breadboard like so, it'll just plug into the voltage rails, and it lets you choose uh, 5 volts or 3 volts with that little thing there, and then same on this side. Unfortunately, it's powered by a barrel jack, and there's no way to use micro USB powering for it, which would have been much more useful to me. It does provide USB power here, so if you have, say, 9 volts or something on that side, you can, for instance, power a USB powered device with that, which is kind of cool, and it has an on-off switch, which allows you to quickly remove power from your projects. So I might use that. I think I may end up replacing this with something that takes USB power, since I have much more often access to USB power than a barrel jack connector, but we'll see how that gets used. Next up, we have this little barometer module. This is a BMP 280. I believe it's called by two names, the BME and BMP 280, and I have yet to learn exactly what the difference is, but this is an I2C barometer with temperature measurement as well. So I'm excited to get started with that. Very small module here, and I believe that this circuitry on the back makes it 5 volt tolerant. I've yet to see if it will work with my 3.3 volt ESP8266 unmodified, because this is level shifting circuitry, but I know that the device itself, which is right there, is a 3.3 volt device. And I believe those pads that you can see right there are for choosing which address, if for instance you had multiple of these on the same bus. I'll get into that later. This device is a 3-axis, I think, magnetometer, which is also I2C. I was really wanting to try out a few I2C devices. Seems like such a promising standardization for sensors. So it seemed like it might be useful. I should mention, I think it might be useful specifically because it can be used to measure things like motors or anything else where you can attach a magnet to it with relatively high precision. This device is an NRF 51822, which is a Nordic Semiconductor Bluetooth low energy device, which is actually programmable, and that's kind of what I want to get into. But this thing is tiny. I don't know if you can tell how small that is. For reference, I'll just show it relative to my breadboard, and you can just see, like, you know, relative to the pins of the breadboard, just how tiny that is. And this thing, I have yet to program it, but apparently there is an Arduino port for it, so you can actually use the Arduino IDE to write code for it, and you will need some form of a code uploader. What I will be using is probably this, the ST-Link, which is used if you have the STM32 microcontrollers. But I also have one of the cheap STM32F boards programmed with the Blackmagic firmware, and I may end up using that. I will report back with what I do. So anyway, I'm excited to get started with that. And finally, this guy. This is a it's the ADS1115, which is a 16-bit 4-channel ADC with programmable gain. So it can be used to measure a lot of different things. I'm going to try to build a data logging, essentially multimeter with it. So that's a project that's upcoming, but this will be the heart of that with 4 channels, It can also be used in differential mode where it only has 2 channels, because for each measurement you use 2 channels, so then instead of 4 it becomes 2. But I may end up using that mode because then it's not based on a ground when you're measuring. You're just measuring from one point to another point, just like you would with a multimeter. So these are today's items. Thank you for watching, and subscribe if you're interested in any of the projects that I might be doing with some of these. Bye.